We're gonna go ahead and call this meeting to order. Just a reminder for all of us that are here on the table, make sure we turn on our mics whenever we're talking. For everybody that's online, if you can please go ahead and share your name before you start making a comment. That way we can keep track of the meeting minutes. The MAC public comment process allows members of the public to comment on items that fall under MAC jurisdiction. I don't think there's anybody in the audience, but if anybody would like to speak at today's meeting, they can complete a speak form. And Gordon can assist with any questions. Also, a reminder for you, Jean and Arvid, to validate that on the stamp. And also, Dr. Mobasher, there's a validation stamp right there on that corner.
Okay.
Yes. With that, let's go ahead and to call to the audience. This is an opportunity for the public to comment on items that fall under MAC jurisdiction that are not on the agenda, informal items or items on the agenda for discussion and not for action. 15 minutes will be provided to the call of audience. And there's a exception. I didn't see any emails or requests come through. Gordon, did you receive anything?
We didn't receive any online comments this month.
Okay. Also, MAC provides opportunity for members to submit comments via the MAC website. I don't think we've received any of those either, right, Gordon?
That's right.
All right. With that said, we'll go ahead into our next item of the agenda, the approval of the February 4th, 2026 meeting minutes. And Gordon is pulling those up as we speak. I hope everybody had a chance to review the meeting minutes. If not, if you can take a quick glance through them, make sure we capture everything correctly. Everybody that has a case has already had an opportunity to chime in and make any corrections. Is there anyone that has any questions in the meeting minutes? If not, I'll entertain any motions to go ahead and approve the meeting minutes as written.
Mr. Chair, I motion to approve the meeting minutes as written.
Thank you, Gene.
This is Roy. I motion to second.
Okay, thank you, Roy. I think we'll move on to roll call.
Thank you, Chair. Let's just go down the list, starting with ADOT.
Yes.
Next is Avondale,
Yes.
Buckeye,
Good afternoon. This is Josh Ford. Yes.
Chandler,
Yes.
El Mirage.
This is Tom Duff. Yes.
Thank you. Florence, Gilbert,
Yes.
Glendale,
Yes.
Goodyear, Maricopa County,
Yes.
Mesa,
Yes.
Peoria,
Yes.
thank you. Phoenix,
Yes.
Scottsdale,
Yes.
Surprise,
Yes.
Tempe, Tolleson, or Youngtown. Those are not present, so motion passes unanimously.
All right, thanks, everyone. Our next item, we are very happy to have a guest come here today to give us a presentation on fiber reinforced concrete. Is Mr. Barsin Mobasher from ASU. I think he's gonna share with us some recent project implementation. With that, Dr. Mubashir, if you want to do a quick introduction of yourself and go from there? Don't forget to turn on your mic. There's a little button. There you go.
Thank you so much for the invitation. My name is Barzin Mubashir, and I've been a faculty member at ASU for the past 35 years. I have built my career around materials in construction, and my main focus is in concrete materials. I'm a member fellow of American Concrete Institute. I've worked with the Arizona Rock Products Association, also ADOT, Maricopa County Department of Transportation. And the project that I'm going to talk about is a project that was sponsored by City of Phoenix and Valley Metro to primarily look at how we can reduce the cost of concrete in the infrastructure, specifically for the track slabs that were used in the second phase of the design for the extension of the light rail. So, allow me to. So I'm going to present about several slides about that project, and then also, in order to advance the subject, I propose the idea that we have the specifications currently and the standards for the use of concrete with fibers from a structural slab on ground point of view, as well as many other structural type applications. The idea is hybrid design, where you can replace some of the congested rebars that we have or reduce the labor cost by simply having the reinforcement added at the batch plant by means of the fibers. And that is the type of work that I've dedicated all my models, analytical calculations and such to be able to show that we do have an alternative procedure for designing reinforced concrete that's not just all rounded up about the use of rebars as such. So next slide, please. The project we looked at it from a large scale testing of a sample of a Valley Metro project. And you can see that's a picture in Tempe at an intersection. The level of cost associated with the extension of with the closure of the road and then putting in the rebar, that was the single parameter that was extending the construction. And many times there was a problem with even the local local businesses who didn't want light rail because it would end up closing their business for about a few months. The idea of taking all of the rebar out and replacing it with steel fiber, it came up at a meeting where I was proposing to do hybrid design, just take half of the rebar. And they challenged me to verify that we can actually take all of the rebar out. The problem with this type of an application is because of the DC current that we have for the light rail that generates potential corrosion cracking in the rebar. So you have to have everything welded together, all of the specs and all of those things to be handled. But this type of a project is not just limited to bridges and light rail and such. We can actually, on any slab on ground, I'm willing to show you that we can reduce the thickness of the concrete simply by putting rebars in there, and I can explain the subjects on. Next, Don. So the idea here was the following. We have basically minimum reinforcement in the context of temperature and shrinkage. Basically, number 5 rebars with also number 4 rebars that were used as the ties. 4 rebars on either side of the rail. The rail is not connected. The rail is not attached. There is a rubber boot that is used to connect the rail. So there is load is distributed by means of the rail on the concrete. So this is primarily a plain concrete. Original thickness was 14.5, and they challenged us to go to 12 inches. So that's about 2.5 inches, about 20% thinner, but take all of the rebar out that is there. So that is the idea that we made about 6 different samples. Standard reinforced concrete, the way it is shown on the left picture, and then just set up the rail and then put in the steel fibers or polymeric fibers or different types. So that was the whole challenge. If we go to the polymeric fibers, and that's what we proved in the second phase of the project, that meant that we just didn't have to worry anything about the potential corrosion of the rebar and the maintenance. That's a problem that we have. So we made these samples 3 feet wide, about a foot deep, and then we tested it in our lab. Can we go to the next slide? So basically the idea was making these mock-up samples, bring it to the lab, set it up, and actually just run the test. But the test had the criteria of 45 years service under the serviceability load design. How do you simulate the movement of a train for 45 years? So we made these assumptions as far as doing the calculations that, okay, assume that every 6 minutes you have a train and the metro is operating, 18 hours a day, and assume that you fill it up with 3 times the capacity at every single time. So you just throw in every safety factor that you want to put in there, and also assume that there is soil loss support for this lab. So you're not counting anything on the soil's foundation support, and you're just basically providing the load as a 3-point bending beam. Apply the load on the rail. Now, to meet that 45 years, you have about 2 million cycles of service load that you have to apply. So we conducted the test as a fatigue test at twice the service load level for 2 million cycles. The entire test took approximately 8 days continuously, 24/7, to run the test. And then in the meantime, we did image analysis where you measure the crack formation in the sample. We put strain gauges on the slab, top and bottom, and then we collected the data. We have a report available. There are papers that are coming out of the work. And the whole idea is to make sure that this technology is used throughout the world. And it is being used throughout the world. Recently in Toronto, they have adopted it for the same type of a approach for the tunneling and the track slab. Next slide, please. So what we did is that the blue line shows you the standard reinforcement, concrete reinforcement. It cracks at about 13,000 pounds. That's when the initial cracking of the concrete occurs with that circle, blue circle. But the fibers that we use, they crack also at much higher load, about 20,000, because the fibers act to suppress the cracks. And I show you those pictures of how it happens. And then after that, you have a residual capacity that the fibers are providing. So the load increases. The maximum deflection that we would get on a section is somewhere about 0.3 inch. But that's a loaded one and if you remove the load, the sample just goes back to recovers at least half of that. So in 8 feet, you might have about 1/10 of an inch or so deflection after the section had cracked at twice the service load. So technically, this is going to stay. This is not going to fail at all. But this is a standard load that's applied. Then what we did is that we subjected them to the fatigue test. And in the fatigue test, can you go to the next slide, please? So here on the right below the picture, there is a icon. If you could click on it, there is a video there that shows how a fatigue test is run. Can you, if you move the cursor on the...
I think it's just moving.
Oh, okay. So there is a sound that you can see. So this is the level of deformation. After first you crack it. So we apply the load, crack it, and then you go through 8 days of just basically this type of a test. At the end, you unload it. So what you see is that, when you go by the end, you still have a lot of stiffness in the section. So what is the worst case scenario? Well, you have a crack that's about 1 millimeter wide. And how difficult is it to repair it? Maybe about an hour or so per crack. You can just saw cut it and then drop in a rebar in there and tighten it. And so this is basically how we can see as you're loading and unloading how this crack is exercised. We used 60 pounds of steel fiber, which is an overkill. So for the next project that we're hoping to do, we want to reduce it by half. So that's going to significantly reduce the cost of the material. We can actually reduce the thickness. I'm willing to bet that we can actually reduce the cost of the material. And we get to the cost issue next. Go ahead. And this is the part that we actually use the fatigue data to see how much does the stiffness reduces overall. And what we find out that after 2 million cycles, and you calculate the average, our stiffness reduces by about 6 to 7%. This is for the after a service life of 30 years. That's basically the estimate that we have. 6-7% reduced the stiffness. It is not going to be rocking. It's not going to be going up and down, and it's basically perfectly safe for the applications that we have. Actually, this is, again, in my opinion, again, we did a tremendous overkill for what we did. Next one. And then, so the whole idea was building up of the project, which was in the, this is basically on the north side. So the cost is just basically the cost of concrete placement or the scheduling time. That's the most important thing. The project was reduced in half by just simply mixing the fibers in there and then pouring it in. So they just couldn't do the groundwork sufficient enough to be able to place the concrete. This application is good for almost any other type of a groundwork application. For bridge decks, we have done a project for pavements now for ADOT, and I have a report on that where we can, why does our thickness of the pavements on the interstate have to be 14 inches thick? How much can we reduce that? And we're looking at it, I can reduce it by 5 inches. You just tell me, how you want to reduce it. Do we need rebar in there? We can put rebar, but we can still significantly reduce it. For pavements, for all of these applications, I have tremendous passion to convince that we're using so much concrete, we're wasting so much material that we can definitely benefit from by improving the quality. Let's go to the next slide. Here is the cost. So, and these are the data that came from City of Phoenix, and I'll be happy to provide you with the report, a detailed analysis. Basically, we reduced some of the thickness of the concrete, 2.5 inches. We took all of the rebar out. It was about half a million ton. About number 4 rebars, about 184,000 pounds, and about 300,000 pounds of number 5. All of that was gone, and we used 60 pounds of steel fiber for that. So basically, there is a reduction, although we were just overestimating. But if you add up the cost of concrete and cost of steel, only if you look at the materials cost, your savings are about $500,000 on a per mile section. The main savings is in the cost of labor and in the cost of construction, because your project per section, per 480-foot section, reduced from 21 days per 480-foot section to 11 days. Cost was reduced by half. Why? Because you had nobody to do field work in terms of tying the rebars, bending them, setting them up, or making all of these cutouts and such. And that differential cost, when they calculated it, the differential per mile went from 121 days, went from 231 days to 121 days. At the end, what mattered for the Valley Metro and City of Phoenix was that the per track foot, linear foot of labor, the cost was $3,300. That was reduced to about $1,000. So that's about 70% reduction in the cost of labor that they had to do. So I don't know how the industry is actually dealing with the shortage of labor or such, but I think that many concrete work can benefit from this. So the final cost of the project, basically from the estimates that they had and the budget, from $17 million, it reduced to $5 million. And that is per mile. And this was just a sample project that we did. And I'm so excited to be able to extend this project, not only for the next generation of the light rail, but also for the future. Now, you might ask, why is this working? Why am I just so passionate about it? Can I have the next slide? And that goes to the fundamental area, because as a structural engineer, 35 years in this business, the ACI code, all of the codes that we're using are concepts that were developed 120 years ago, when even a hand calculator was not even available. So the equations that we use for flexural capacity, the first day in class, we tell students, concrete has no tensile capacity, ignore it. 150 PSI, 200 PSI or so, we're not going to count on it because we don't know how easily it cracks under tension. And that's why when you do all of the calculations, we're still using the same equation that was developed before World War II, before even transatlantic flight was possible. I mean, 1907 it was developed, 1930s it was codified, and we're still using it. So what we are saying, next slide, is that if instead of rebars that are, for example, here on a pavement, are transferring the load only from a shear point of view, we use fibers. The fibers are crack arresters. They won't even allow the crack to propagate. They make it difficult for the crack to propagate. So for cracking, you need energy, and that energy is sucked up by the fibers, by friction, by pullout, and by all these mechanisms. They hold the cracks together so that your aggregates now are providing the interlock. So it is a symbiotic relationship that you don't just basically put one rebar thinking from a macroscopic point of view that rebar is going to carry all the load. But before the load actually is able to come to it, it's going to basically be carried by the fibers across. And this is what I've dedicated my career to. Next slide, please. So we have done the calculations. We've simulated that even if you have cracking, how much that reduce the stiffness is going to be able to stop it from any kind of a vibration, any kind of a problem? Answer is no. We can actually simulate the result that the fact that the material has a reduced stiffness is still acceptable from a load carrying capacity, weight of the system. But this can work for traffic, for light rail, and many other. If you're designing or approving a design for, let's say, a warehouse, for a data center, for any kind of a system, slab on ground. This is a quality engineering object. So I don't know if you want to look at this saying that we can reduce the cost of the projects that we are planning significantly by taking a big bite out of it. 80% of the fibers that are used in industry are for slabs. And ACI, we have been developing in conjunction with ACI 301 specifications for concrete. We have developed a committee report 544-12R that I'll be happy to provide it with you. That is basically provides the specifications for the design. So from implementation, all a structural engineer has to do is to say that, okay, the concrete can have fibers as long as the fibers meet this type of a minimum requirement. So this is a performance-based specifications. Your concrete doesn't have to have 3 pounds or 4 pounds of fiber. Show me that once it cracks, that concrete can carry about 150 PSI. The standard is 544.12R, and it was published in 2023. So I feel that we can actually do that. But my next project actually personally is to look at from a fundamental structural designs where we are talking about tracks from tunnel linings, from other applications which are from steel mill design where you have to have slabs where you're having 50-ton cranes moving the material. So that's the part. Next slide, please. I have a bunch of pictures of what we have done for SRP, reducing the thickness of precast elements. You can go from 8 inches to 6 inches, reduce the thickness, take the rebar out, and it's a lighter material. So now you don't need huge cranes to carry 11,000. You can just carry something like 5,000 pounds. These are the challenges that I cannot put my finger on because I am a structural engineer. But for those people who have to write the checks for for all of the logistics of movement, the reduced weight, not only it's a reduction of the material, but it's the other ones. Next slide, there are about 3 or 4 slides. We do finite element calculation. So this is for water retainment or distribution system. Next slide. And you can see how much it reduces. We've done projects for shotcrete. You can specify if there is a ready mix or precast plant, we can make septic tanks that are 2 inches thick with the same material because you don't have to put in 2 inches on this side and 2 inches on that side to provide for you for the cover because the cover is not important. You can make it with polymeric fibers. SRP only has 2 weeks to repair all of them. So you put polymeric fiber in the shotcrete. Again, you don't need to do wire mesh and such. So go ahead. So these are all projects that we have reports for. We require a test and we conduct a test that's fluxural. We crack the concrete and then allow for the fibers to get engaged. So technically we're depending and designing based on how much fiber is carrying. This is not just basically a performance. Next slide. So we have basically all the model development. I don't know, how much time do I have?
I think we've had allowed about 15 minutes, but if you.
So I can just go through it. We have models, we have design equations. Actually, there is a project that I wanted to share with you, and that would be a project that Maricopa Department of Transportation picked up. Can we go to the next slides? Yeah, just go through this I can skip. So basically what we see is that we show that I'm going to saturate this sample with cracks. It's not going to give up until all of these radial cracks form in that panel that I'm testing. It's not a single crack that easily grows. And those calculations basically take you to the figure on the left. The green line that you see is basically what the fiber concrete is doing by itself. The blue line is when you design it by reinforced concrete. In other words, it cracks, but it takes a time for the rebar to actually start carrying the load. That gap that the rebar is carrying the load is picked up by the fiber. So if you combine the fiber with the rebar, you would all of a sudden more than double up. So the idea is that if you're doing reinforced concrete, putting fibers in is going to double up your strength, because now your response is going to be pushed up to the level, much higher level. So that's the magnitude of moment capacity. And we have verified it by so many experiments that has looked at what is this effect of adding fibers to your original fibers for rebar. But what you can do in return is to take out some of the rebar, reduce the spacing, or increase the spacing from 6 inches to 12 inches or so. Go ahead, next slide. Next slide. And we have done these projects for SRP. You can see on the bottom, many times structural engineers are worried. So what you see, the hole, it's called a punching shear behavior. The slab is so thin that it just basically, like a stapler, it punches out. But if you have fibers, you completely get away from that shear failure, and now you have basically a distributed crack system that the system doesn't give up. And these are the type of experiments that we've done for plastic design, making and testing these panels. Next one. This is the UHPC project. Maricopa Department of Transportation had to replace several bridges, but the budget that they had was only for one bridge because of the cost of replacing the bridge. So what we proposed is to use UHPC. This is ultra high performance concrete, which has about 3 times the fiber content that is in the project that we use for track slab. It has about 2% steel fibers and a lot of super plasticizer. But I can verify that every single ready mix producer can make this in Valley, because they have now, with the cost of one bridge replacement, they have rehabilitated more than 7 bridges, extended the life. And the reports are available. Jimmy Camp, who's the head structural engineer, he's just totally bought onto it. They have transferred. The idea is that if you're replacing a bridge, you can order precast girders, and when you put them in there, for connection pour, you use this ultra high performance concrete, which has a tensile strength of about 2,000 PSI, compressive strength of 20,000 PSI, which means that this thing is not going anywhere. This is going to glue everything together. And the project basically is just, you use a small amount, you use about 1 truckload for an entire bridge of this UHPC. Next slide. So these are some of the pictures so the track slabs are put in, and this was done in Palo Verde Bridge in Buckeye about 3 years ago. And from that point on, they have taken on their own. So every two weeks or 2 months or so, Jimmy sends you an email, oh, we just finished another project here. So in other words, we've trained the technicians, we've trained the engineers with the Maricopa, and also worked with 2 different companies that are contractors and subcontractors. So this technology transfer, I think, is really important for any activity that we would want to have, to be able to transfer that knowledge and actually participate with them. So other counties, I believe, in the state can also benefit from it, especially when you go to I-40 or Northern Arizona region. Go ahead, next slide. So here is the cost of approach slab. So the figure on the left is the approach slab, which is traditional concrete. Compared to the cost of this is just, you can't consider how much the difference is. But you can certainly see that the entire bridge on this project was replaced in a matter of 10 days. So if you have any cities or municipalities that are pressed for time in terms of being able to open the traffic, this type of an approach of UHPC is extremely important. Again, we're developing the codes for it with ACI Committee 239. Next one. And we've done again the same. Everything we do has to be verified with full-scale samples. So we collect samples and then we test them. Next slide, please. Okay, here's a video again, if you can show. As we apply the load, we measure how the load is, and it completely fails. And you can see that the deflection, almost about 1.5 inch deflection, that 6-inch strip, after 1.5 inch deflection, is carrying 8,000 pounds of load. If you look at the load, how it stabilizes. So there is, the question of this surviving is not even a question, because this is so over-designed and so useful because the labor is there. People are standing there watching because this is a self-consolidating concrete. It just fills the hole, and then you just have to finish it. Next slide. And of course, everything we do the simulations, we measure, 20,000 pounds of force applied on 6 inches of concrete. And it's a flexural beam. So, all of those design calculations can be just done with the software that we have. Okay, next, I think I'm pretty much, and this is again, this bridge was supposed to be completely replaced because those connection steel sections had to be taken out. This was another project, Centennial Bridge in Maricopa. And again, it's in remote area, so it's difficult to mobilize, get people there, get concrete there. But still, Jimmy and his team were able to just get things set up. And the idea was here to replace those connections with UHPC. So next slide just shows again some of the applications. So those keys were replaced. We call them staples. So basically you just drill, finish it, and then you do the entire overlay. So a 2-inch overlay, it doesn't add anything to the weight, but then it just gives you 30 years of service life for the bridge. And the steel rebars, no, they don't puncture the tires. They don't create any kind of a problem. And so there is no potential for corrosion there because they're this. Next one. And that's what you will see in some of these sections. It is a different animal. For anybody who's worked with it, they realize that this is not your conventional concrete. It flows differently. It's a thixotropic. You don't need any vibration, actually. It just flows under its own weight. But people are just basically finishing it. If there is a chance to see some of these demos, I'll be happy to share with you and then let you go and experience. The material is pretty much like molasses. And then you can do a complete bridge overlay with concrete that's going to survive. So any kind of a repair, rehabilitation, or new project or reduction for along highways or along surface streets and such, this technology is available. There are several resources in terms of the fiber producers. They have the design guys, they have engineering team to do the quality engineering. My team is available for any kind of a testing. There is a local company that makes the test equipment. And I think that implementing this type of a project can pay for it on the very first project. And you can basically benefit significantly from this significant cost that's growing. I should stop here. I think I've talked too much. I apologize.
No.
But I'm excited about it because I think that, listen, I'm a state employee. I want to help my state as opposed to being called to go all over the world and give talks about why this technology is working.
Thank you, Dr. Mubashir.
Thank you.
Definitely great presentation. I guess I'll open up to the people online first. Is there any question?
Hi, this is Warren with City of Chandler. A couple of questions. Thank you very much for the presentation. Very, very interesting. I just hadn't really dove into that in a while, so that was very educational. The fiber reinforced versus traditional concrete, do you have the normal requirements for expansion contraction joints, or is that not needed? That's one question.
Actually, we have done projects where we totally eliminated or significantly increased the joint spacing, or in certain cases, eliminate all. The beauty of the system is that you don't need to predetermine where you want the joints to be there. If the fibers are sufficiently, they redistribute and don't let the cracks to localize into some kind of a random cracking that starts opening up. There will be a lot of tiny micro cracks, but they're only surface. So maybe just 1/4 of an inch or so they go in. And we have enough data to show how they can actually, the cost of joint maintenance evaporates.
Thank you. And then also you showed the picture with the fibers and the raking. How do you ensure that the fibers are distributed well enough within the area that you poured?
Okay, that's a great question. The idea here is that the fibers across the thickness of the section, so look at that crack that has gone almost 90% of the depth of the section. However the fibers distribute, all of those fibers are contributing to the carrying of the load. So maybe you would get 20% higher content at some point than some other point. But at the end of the day, what the section sees is a force that's applied on top of it. That force creates a moment, bending moment. That bending moment is distributed over the entire section. So the areas of the, it's like, I guess, just the idea is that the areas that have a lot of fibers, they carry more of the force than the areas that they don't have, because the cracks are not going to be continuous anymore. The cracks are basically distributed throughout the entire volume. So the idea of getting a uniform distribution of the fiber is immaterial, because what we calculate from the contribution of the fiber is the force across that entire cross section. That force again is integrated to give you the magnitude of the moment that's applied. So that moment is the one that the fibers are averaging their performance double time. So you integrate that contribution twice, which means that you put all of them in a bag, and that bag is the one that's carrying all of the load. So we have all of those calculations. There is tons of work that we've done in terms of actually addressing this from quality control. Many times you have a specification that says that, oh, your standard deviation should not be exceeding this level. Well, the standard deviation of a single test that's in here is not significantly that important, because it is the collection of, you saw all those radial cracks that we have in these slabs. It doesn't matter which crack occurs first. Normally, it is the weakest section is going to crack. But that crack is not going to be able to be allowed to deform until every other crack forms. So you get this complete plastic behavior where, there is a whole, basically from a plasticity theory, you get the whole deformation happening. So it is not just the weakest point that controls the performance. It's the average number of cracks that you need to form, whether 3 cracks in a shotcrete, which has only about 4 pounds of fiber in there, till the sections that we have tested, which has 60 pounds of steel fiber. So the more fibers you put, the more these cracks get so close to each other that you can't even see it, but then it has already cracked and it's deforming. So it goes back to how critical the structure is for many applications where you have environmental applications, environmental areas where you don't want anything to leak out. Then what we can do is to put enough fibers so that the crack width is maintained. That means that permeability, the water tightness of the section is actually addressed because the cracks are closed. Significant.
Thank you.
Anyone else online has a question?
Yeah, Mr. Chair, I've got a few questions. So, first of all, as a graduate of Arizona State University, I'm glad to see there's still professors, and I'm not recent. I've been there, I graduated quite a while ago. It's good to see that there's still some of the same staff.
Thank you.
My first question is, you talked about the study you did at the light rail and comparing the standard design that had the number 4 and number 5 rebar. And then you did quite a bit of optimization, it sounded like, to determine what the necessary section was using the fibers. And then you compared the cost of the standard design to the concrete using the fiber design. But has anyone checked to see if the standard design was also over-designed by 200% or 300%? Was there a standard design that was more efficient that would have reduced the cost? In other words, are we comparing an optimized design using fiber reinforced concrete to an over-designed standard design?
Okay, I got several different ways I can answer your question. But the first thing is that we were on a limited time. There was going to be a ballot measure that had to be decided on whether to go forward with that extension project or not. And we were under the gun to come up with a design that's going to guarantee that we're going to reduce the cost. So in the project that we worked on, the design was already approved. The single most challenge that we faced was convincing the structural engineers and the company that had approved the design, and they had almost done it, to be able to accept the revision that we proposed, which was a reduced cost. Now, we were conservative also because we only got one chance to prove our case. So at that point, you say, I'll eat the cost. I put extra $100,000 into the extra fibers, and we're going to make sure that it works. Now, when you talk about the cost, I did not do any optimization. The cost numbers that I showed you, they were provided to me after the project was constructed and finished. So those were the real costs that they compared. The answer to that is, so finally I can say that yes, even the designs that we are working on today, if we can develop a little bit more testing and validation, we can actually meet the specifications that the engineer says. When we were told that you have to make sure that this thing is not going to need any serviceability requirement for 40 years, that makes you a bit nervous as far as how am I going to do it. And it's in the public's eye. Everybody's using it. So I think it was over-designed. Yes, you're right. It was 200% over-designed, but it wasn't, but our job was to at least save. The main cost savings are in the labor. And I don't want to just simply say that my design was better or not. No, we still had a very over-designed system. But the fact is that the labor is the variable that we need to get our hand around.
A second question, you talked about, if I understood correctly, one of the differences is that with the fiber reinforced concrete, there's a lot more micro cracking versus larger cracking. I guess the question I have for you is, with a lot of micro cracking, is there not an issue with water infiltration that might corrode the steel fibers?
No.
And if the steel fibers are small in diameter, and any corrosion that occurs on them would seem to have a major impact, versus if there's some corrosion on a large diameter rebar, it takes a long time for that corrosion to start having a big impact on the structural integrity of it. So I guess talk to me about the micro cracks and the water infiltration, and how does that affect the steel over, a 40-year life service like you're talking about?
Sure. There are several ways I can start, but the simplest way of starting here is that, first of all, when the fibers maintain a much, much smaller width compared to if the cracks were not unreinforced. If the crack is unreinforced, you normally get one macro crack, the way, for example, a pavement degrades in concrete. So it just basically you get chunks off and such. We never get there because it is almost one of the biggest challenges with this is how do you remove it? You have to saw cut the concrete to remove it because the fibers are holding it together. Now, the issue of the water permeability, yes, we have test data. A lot of my colleagues have done test data. What we know is that, first of all, you need to have a lot of salt. This is a problem for, the corrosion problem is primarily you need to have lots of water and chlorides and salt. In Arizona, we are very lucky that we don't have those types of exposure conditions. Now, what matters about permeability is that the width of the crack has a cubic relationship with amount of water that penetrates. In other words, a crack that's twice the size of the original crack allows 8 times more water to penetrate through. So it just basically, without any resistance, goes in there. But if you have the cracks, many times the cracks are going to get sealed because if you don't have improper hydration, which in many concrete we have, you get calcium carbonate forming because of carbonation of the concrete. This is what people are making tons of tax reduction by just simply saying, oh, my concrete is carbonating. Now, the carbonated concrete calcium carbonate has a higher specific gravity, which means that they call it self-healing. I don't really subscribe to that type of an idea. It is just basically conversion internally. So self-healing, it limits. So it's small cracks. It just basically is like crazy glue in the crack. So it just basically seals it. So technically, now when you go to the fibers, corrosion is an electrical cell, like a battery. You need to have, on the same steel, you need to have both an anode and a cathode. In other words, you have the positive pole and the negative pole. The steel fiber is so relatively small. And then at the same time, the biggest problem with concrete cracking due to corrosion is because the rebar generates a lot of stresses if it's so close to the surface. That's why we prescribe the concrete cover. The stresses that generate around the fiber that's 3 inches, 4 inches deep inside, it would never generate enough stresses to spall off the concrete. The problem with corrosion is the spalling of the concrete because the rebar generates tensile stresses in there. And the tensile stresses here, don't develop because the not, first of all, the fibers are not point-to-point contact, so we don't have that continuity for the cell to form. This is the problem with the rebar in a track slab or anything of that nature or any other kind of a system, because it acts like a transformer. So the DC current has a field, the electrical field generates a current. The current has to go from one node to the other node. And that flow of the current and the separation between the two generates the current that causes the anodic reaction and the cathodic reaction. So it is not possible to generate all of that. It's possible to corrode a single steel fiber, but you really have to create two nodes on the side. So the same portion of the fiber has to be grabbed by the two electrode ends and then forming it. So we have done a lot of, I've done studies where we've done 2 years analysis of cracked concrete subjected to fiber, subjected to corrosion. So we have salt solution, carbon dioxide, all of these things. We have tons of data to say that we can reliably design it. And it's being used everywhere in the world. In terms of, some of the most critical parts of the world, Sweden, Denmark, those areas where they have a very harsh climate in the coastal regions, they use that.
So one last question, and this is just a brief question, if you don't mind, but so if you were looking at sewer infrastructure that might have other types of corrosive materials, with salts and whatnot, would you recommend polymeric fibers, or do you have a preference? You focus a lot on steel fibers, but you also mentioned polymeric. Is there
polymeric
a preference
fibers?
that you have?
Polymeric fibers are as good, and we can actually make polymeric fibers, the mixed designs, just so that they compete one-to-one with the steel fibers. And that's exactly what the Valley Metro wanted on this project, to be able to get the data that would validate that we can use polymeric fiber. That way, any question of the steel fiber is put to rest. Actually, the idea of the sewers is a perfect idea. There are pipes made with polymeric fibers. It is because of the sulfuric acid that forms, or H2S. So definitely the idea of concrete pipes, I don't think they should be turned over and let, plastic, pipes to be using it, simply because I believe that we can easily handle that, and there would be no problem with the corrosion of the polymeric fibers or concrete with polymer fibers. It can meet all of the specifications, and there are pipes available that are using that. I've worked on some of those as well.
Thank you very much.
You're welcome. Anytime. Thank you.
I guess this is a great topic because I have some questions on myself, but I know in the interest of time, I do want to open it up to the floor to see if anybody else had a question. There's a lot of questions. Does anybody have a single question that I want to walk away from?
I just wanted to mention, many decades ago, I worked on, when I was SRP.
Yes.
So I was glad you showed the SRP data. I worked on the specifications when we were starting to introduce that on, on Shotcrete.
Yes, for
I
sure.
actually was one of the writers of the Shotcrete spec.
Yes,
With
yes.
the fibers. And there's been a long history of good success with fibers with the shotcreted SRP. Although we didn't eliminate the jointing,
Yeah.
when you said it expanded out, that was good.
Yeah.
But we didn't eliminate jointing on that. But there's a long history on using fibers in concrete in the valley. You just have to know the application. I think in terms of flatware,
Yes.
that's where we have the greatest gain. Some structures, I think scuppers would be an interesting place
Yes.
to look.
All right. Again, thank you, Dr. Morbash.
My pleasure. I'll be happy to help the MAG,
I know.
and I'll be happy to provide, share information, share reports that we have, answer questions. It's our job.
Yeah, there was a push, I think, a couple of years ago or last year about potentially starting to modify some of our details where we're calling for a nominal amount of steel on some incidental structures.
Yeah.
I could
We
potentially.
can
be-
definitely do that. And I can provide you with all of the spec guidelines that you can refer to them and use.
Thanks, everyone.
Thank you.
We'll go ahead and move on to our first case. Case 25-12, revisions to sections 326 and 719 for design and placement of polymer modified asphalt concrete. Alex? And real quick, I forgot to say, that you're welcome to stick around, but feel free to take. I appreciate it. sir.
Thank you so
Thank
much.
Yes. Sorry, Alex,
Thank you,
go ahead.
Mr. Chair. Nope, that's fine. I appreciate it. We got the comments back specifically from the city of Phoenix about laboratory qualifications. Worked with your group to incorporate those. They were somewhat minor modifications specifically to any lab that was going to be performing the performance analysis. So if there were no other comments received, we again would like to move this forward for a vote next meeting, if that's possible.
It is up for a possible action. I know this case was part of the agenda package for anybody else that's online or got a chance to review. I will pose a question out there. Does anybody need more time to go through the final revisions or get back with their staff at their agencies to get any final buy-off on this? So I'll take that as a no. With that said, because it's up for possible action, we can go ahead and call for a vote. So I'll entertain a motion if somebody is willing to.
Mr. Chair, this is Warren from Chandler. I motion to approve.
Thank you, Warren. Do we have a second?
Mr. Chairman, this is Dan Nissen with City of Peoria. I second that motion.
All right. With that, we can go ahead and take a vote.
Thank you, Chair. Okay. This is case 25-12. ADOT,
Yes.
Avondale,
Yes.
Buckeye,
Yes.
Candler,
Yes.
El Mirage,
Yes.
Gilbert,
Yes.
Glendale,
Yes.
Goodyear, Maricopa County,
Yes.
Mesa,
Yes.
Peoria,
Yes.
Phoenix,
Yes.
Scottsdale,
Yes.
Surprise,
Yes.
Tempe, Tolleson, or Youngtown.
Yes. Tempe.
Tempe joined us. Thank you, Chair. Tolleson or Youngtown? Okay, looks like the motion passes unanimously.
I appreciate it. Thank you, Mr. Chair.
Thanks for all the hard work. I know it was our last remaining carryover case, so
Thank you guys. for
it's
your
good
help.
that we got it through.
Excellent. I think that's great. Thank you.
Alex, is there any chance that we'll put steel reinforcement in it later?
We'll look at that for next year.
Congratulations, Alex, getting that over the finish line.
Right, let's go into our 2026 cases. I do not believe there's any other miscellaneous corrections, right, Gordon? Have you received any?
No new ones this month.
Item number 7, case 2602, revisions to details 206-1 and 206-2. Concrete scupper, Gene, can you give him an update?
Yep. Thank you, Mr. Chair. I'll start with the correct case this time. You go to the second page there, Gordon, there's some proposed language change there for note 5, safety rail shall be continuous and extend to the outer angle point aligning with the 1/2-inch expansion joint. This is one of the suggestions for that language modification. Then also look at incorporating note 8 for the slope tolerance to meet 0.5% to 2.1%. And then also on the cross-section CC, add in target slope of 1.5% just to stay consistent with the sidewalk with the PROAG and all the work that Warren and the ADA working group has put together. So there's that. And then if we jump into detail 230, which should be, yep, there you go. Initially, there wasn't going to be I didn't anticipate any changes to this detail, but I think what we need to do is on note 7, we need to modify that tolerance to 0.5% to 2.1%. I believe the original detail indicated 2.0%. So we'll move that to 2.1 to stay consistent. And then I would suggest to the committee that we remove the blue underlined sidewalk not intolerant shall be removed and replaced by the contractor. This is already spelled out in section 340.3.10 under deficiencies. So consider removal of that since it is a redundant statement. That's all I have. This came in late. I appreciate, Gordon, I appreciate you getting it onto the website. I know you guys, most of the team members here haven't really had ample opportunity to look through this. So in all fairness, I'm fine with the committee chewing on it for another month till next meeting and bring the questions. That's all I have for updates on this case.
Thank you, Gene. I will say we can put it out for potential action on next month, but I would definitely encourage everybody to get with their groups. Definitely on the language, right? We can all type something up and understand what we want to say, but it doesn't hurt to get a couple of set of eyes on it. Does anybody have a comment on what Gene just presented? Oh, go ahead.
Mr. Chairman, I just had a question on the very first detail on the positioning of the pipes. Go back one more. That one there. Okay. So it shows a railing out in the embankment and or soil landscaping. The ones I've seen, I was actually driving around, I was looking at a few of these. And one I saw had a bend at that point and put it on the concrete. So that it wasn't a straight railing. It actually, the ends were bent out. So the post was on the concrete.
So it turned a 90?
Not a 90, it was more like, 15, 20-degree turn just to move it onto the concrete. That way it eliminated the need for any kind of separate foundation out there.
That's how we do ours, like that. We don't, I mean, we have on a special case, had a two different methods of pole mounts like this on the detail, but most of the time we try to do all on the well plates on the actual concrete.
That's what I saw too. I was noticing both Chandler, definitely saw it in Chandler. I thought I saw one in Gilbert the same way.
So to that point, yes, there is more than one way to plate this or to attach those extensions. If you look at the standard detail 145 that's called out there are different. I did not include that detail in here, Gordon, but there are different methods to attach.
Is there a separate foundation detail? That was my
yes. This
concern.
is type C. Type C is a direct bury.
Okay, so there is a foundation.
Yeah,
that was the thing. I didn't see these in these details.
Yeah, there's a cross section
Okay.
in 145, detail 145, and I can include that in the more refined version that I'm going to put out with the cover sheet updated. I can include 145 detail in there so we don't have to thumb back and forth.
Yeah, that was my concern. There's no foundation.
My concern would be if we are angling them back like Jim had alluded they are doing and bringing them, if I'm running a 4-foot wide sidewalk, I want to maintain that minimum 4 foot wide. I'd hate to put an obstruction on the edge of that sidewalk. But here's the different cross sections that Gordon had brought up. Type 4, I'm sorry, is the direct bury
there it is.
that would go extend beyond.
Gordon, would you mind going back to the detail that Gene was working on? So, because I think the dash one, 206-1, because you had used different, you see the squares are supposed to be the well plates and the circles are supposed to be the actual. Yes.
Yeah.
Is that where you were thinking maybe adding some clarification of what those mean?
No, it's more of a.
Are we making it more busy than? I understood the intent.
Yeah, it was more of a way to describe it simple to the group, a visual. Honestly, those red squares and circles could really come out of there because it's redundant now with the next detail, so.
That was the concern. If it shows like that, then that's what they're gonna build.
Yeah, I would certainly, I can remove those. I think to your point, it's not necessary to have it in there, being that it's attached on another detail. That was more for the committee to kind of see where, where everything's landing.
I would say I differ in that opinion. I think this will help reinforce.
The other dash,
Currently, I mean, the railing is already shown on -3, right?
it is,
But we're still having issues, the reason for this case.
right.
So I think it doesn't hurt to just reinforce the idea of the limits of the railing.
Well, and where the confusion is coming in is if you look at -3, Gordon, if you want to pull that up, you can see the spillway there. Now, it would be perfectly fine to have that rail to the 2 weld plates and stop it there. Structurally, it's not as sound as if you tie it in further out into the soil. They do get knocked over a lot easier. But if your grade, if your parkway grade, if you're up to concrete or one inch below finished concrete grade there, you don't have a hazard. You're not posing a hazard. If those not wing walls, but those channel walls are up high enough, you're not creating a hazard. But with the riprap channels, they're, by the time they come out on their slope, we're way further than that. And that's why we need to have that extended railing on there.
And the 2 I was looking at specifically did have the riprap.
Yeah.
And it was sloped back. So what they did was come in, you see where the concrete bends before it gets to the sidewalk. That's where the post went.
And I had another contractor come out and just weld on, not even do the 145 type 4 or whatever it is. He just welded on little wings on the end of that centerpiece that's on the weld plates just to capture an additional 1 or 2 feet of potential hazard. But that's what we're proposing over at Glendale. If you guys can think of, committee members can think of a different modification that they want to, put out there, I'm certainly open to that. The whole goal is just to protect from a liability standpoint. When you have that drop off, you lose a wheelchair wheel, whatever it is off there, somebody goes for a ride and we end up having to pay the bill.
All right. Does anybody else have any other comments on this case?
Yeah, Mr. Chair, just real quick question. It was mentioned that we're changing the slope potentially to 2.1% as a maximum conforming to the ADA. Can someone remind me how we came up with 2.1? I think ADA specifies a 1 to 48, which is like 2.08%, and we've traditionally had 2.0%. 2.1 is technically above the 48 to 1, or 1 to 48 slope. Is it just for rounding purposes, or how do we come up with 2.1%?
So that,
Do you want me to speak to that, Jose, from the final PROAG perspective?
I was going to request that, Warren.
Oh, okay. Jose could do it as well. That's what they decided to settle on in the final PROAG, Ryan, the 2.1. Just to keep it simple, I think. I forget exactly the dialogue, but that's how it's stated in the final PROAG.
Oh, so PROAG specifies 2.1% then?
Correct. And that's what we had updated last year in section 340 to be consistent with the latest PROAG.
Yeah, and I remember, I couldn't remember the details on why, and I was going back and looking at the standard details, looking at that, and I didn't see that. We have a handful of other details that still call out 2.0%, such as the driveway details and others.
That's
true. Just trying to refresh my memory on that. Thank you.
So, Mr. Chair, to Ryan's point, those other details, do we want to do it in conjunction? Do we want to fix those in conjunction? I don't think they're really related to this case, but to Ryan's point, we probably ought to clean up those other ones. Maybe we do them subsequent to this case. We could look at the driveway and the other ones.
if you don't mind taking on that challenging as part of this, that'd be
But not in conjunction with this case.
I think we have had that discussion because I was potentially considering maybe just do a general miscellaneous correction across the board, but
Boom. I kind of like
but
that.
if we have a case, that's probably the preference, right? Gordon, I think that's what we're
If you're gonna
discussing last
be,
time.
Okay.
yeah, if you're gonna be updating a bunch of details, probably would want to make it a new case.
Okay. Yeah, thank you. So it'd be subsequent to this one. Thank you for pointing that out, Ryan.
Anyone else has any questions on this? All right, moving along. At number 8, case 26-3, revisions to curb and gutter details 220. Gene?
Yep. Thank you, Mr. Chair. To this one, I took basically all the comments from committee members and I went through, marked everything up again. I apologize for everything coming in so late. I know committee members haven't really had an opportunity to digest any of the proposed revisions. So I'll start with the vertical curb and gutter type A. At the previous meeting, we discussed extending that line just to the flow line, the horizontal line to the flow line. And then the dimension would be 1 inch for the slope there, 1 inch over, well, 1 inch in height over the run. Then also 6-inch minimum. I don't know if you can zoom in on, that's kind of small that I wrote it. I don't know if the committee members can see what I had put in there, but, or just take my word for it. For the thickness in front there, we had gone to 6-inch. I just suggested minimum, and then to a couple committee members' comments, leave that the bottom horizontal plane there, the subgrade of the curb and gutter as an optional dimension, as long as we hit that 6-inch minimum. Then over on to, I just brought that across on all the details. You go over to type C, the rolled curb and gutter, same thing. So if this one in particular, Gordon, can you go to the last page real quick to this case? Right there. So you could look at this one, see the 4-inch. I had just basically cut and pasted it over to where the bubble is, the red bubble. So I'd move that over, and then I had taken the 6-inch minimum and I had just skewed it up because for some reason it was at the subgrade. Well, I know why it was there, but I had made it so that from the lip to the subgrade is 6-inch. So now, Gordon, if you want to go back to the first page there. Yeah. On type C. That's what it looks like after it was copy and pasted. Just as simple as that. And then also left the subgrade as optional on that one. And then in type D, propose optional. Now it doesn't necessarily need to read optional between those two lines. I'm just putting it there for illustration purposes for the committee members. How that CAD work looks, that's a whole nother conversation. If we want to go to -2, 220-2, yep, there you go. Type E, same thing, incorporated that 1-inch dimension, 6-inch minimum for the height of the thickness of the curb, and then also that optional there for the subgrade. And then I carried that over also to type F. Same thing. And then I believe I included, I want to say it was ADOT. Mike had brought up the ADOT detail. So I threw the ADOT detail in there for the committee members if they wanted to take a look at it, because it was brought up at the last meeting. So that's all I have for updates on this case, Mr. Chair.
Thank you, Eugene. You know, one comment I would say, and maybe suggest that if you don't get any comments on this over the next month, maybe because of the intricacies of this particular drawing, probably get a cleaned up version on the committee so we can really chew on the proposed changes. It's a lot.
Yeah, no, and I can appreciate that. I think right now I'm to the point where I don't want to put any CAD work into it until we all kind of agree on the direction it's going.
Go ahead, Alex.
I have a question on one of the previous details. Gordon, if you could back up. I believe it was.
It's, Alex, it's not polymer modified.
Does it have fiber?
It used to be.
In the upper right-hand corner, I believe. Not sure if that one
Type
right
C,
there,
yeah.
where you have the 6 inches minimum, how that line looks to me, that appears to be the edge that's exposed to the asphalt is 6 inches. Therefore, in the belly of that curve, you could potentially have thinner than 6. Is that?
You would,
Is that
yeah.
the intent?
Yeah,
Okay.
that's across all of them, because you're gonna lose an inch. On all of the cross sections, you're gonna lose an inch between flow line and the lip of gutter. Yeah,
that
no,
was
that's a
just
great
the-
observation, though.
Okay, thank you.
And then you do have your 1/4 inch above grade there for the asphalt, where you set your lath down and string line. Yeah, you see in that drawing there, type C, you see you lose a 1/2 inch right there, right? Because of the flow line, you lose a 1/2 inch off that little triangle right there. You lose that 1/2 inch. Thank you though, Alex.
Any other committee member have a comment?
Actually, I get my camera to work here. Just to follow up on that, Gene, you said that they all lose that inch or 1/2 inch or whatever it is, but I didn't understand it that way. I thought all the rest of them are measured from the flow line and saying, which is the lowest point of the surface of the concrete, is 6 inches minimum thickness. That's the only one that's not measured from the flow line. So I think I have the same question Alex does. I think my understanding is the rest of them have a 6 inch minimum thickness of concrete anywhere on that gutter pan, except for that roll curb one.
So you'd have to create a flow line at some point, and your flow line, you'd have to have a slope. So you'd have to thin up at some point. Now, if you wanted 6 inch minimum, you'd have to have your 6 inch minimum at the flow line. If you wanted to carry 6 inch minimum all the way through, you'd have to have it at the flow line, that dimension. And then you would be 7 inch at the face of the curb where the form goes on.
Sorry, I guess now that I'm looking at it, I see what you're saying, but my understanding from our original discussion last month or whenever, I thought what we were saying is that 6 inch minimum was the dimension from the flow line. The thickness of the concrete anywhere along there would be 6 inches minimum. And so that would be measured where it shows optional now, it's measured basically to the point directly below the flow line is 6 inches. And if you have the slopes match, it would stay a constant 6 inches. But that if you chose to not have the concrete slope like that and just to match the subgrade, it would increase from 6 inches to 7 inches. That was my understanding of what we were proposing to do. I see that it doesn't show that. So I guess either I misunderstood it last month and maybe I'm the only one that was thinking that way, but I'm seeing it different now than what I thought we were planning to do.
So to Ryan's point, Mr. Chair, that's 6 inch. Do you have a comment?
No,
Okay.
I would say, I think I agree with Ryan, what he's saying. I think the intent is to skip 6 inches across the gutter, the pan of the gutter.
No, the intent was to lose the bottom optional, to lose that bottom section and make that an optional dimension. Because they weren't calling out they were showing the 1 inch up at the top of the flow line. So if you take the 6 inch minimum, that was always 6 inch. It was never 6 inch minimum. Ever since history started with this detail, it was 6 inch. Then you take your curb face, that would be 6 inch, right? Your height of curb, H equals 6 inch or specified on the plan. So let's just call it 6. you could have a 12-inch back of curb, right? Well, you got to lose an inch in there somewhere to get a flow line.
Can we put up the original detail?
Yeah, I think that is well, it is pretty much the original detail. I didn't change any of the lines on it. Only thing that's changed is in red.
Oh, okay, sorry.
Okay, I see where you are saying your argument, Gene, but then maybe because I still thought that we were gonna get a 6-inch pan no matter what. Maybe is it better to put the 6-inch minimum right at the 3/4 inch radius?
I think my point, Mr. Chair, is we never had a 6-inch pan.
Oh, okay.
You always had to lose an inch because if you're back, I wish Gallimore was here. He could help elaborate on it. But if you had typically your back of curb is 12-inch.
Yes.
If you had a 6-inch curb face and then you had a 6-inch lip of curb, you'd have to lose.
But Gene, where do you get that's 12 inches? The back. That's not
Because-
called out. The way I've always interpreted this detail is where that 6-inch dimension is showing the thickness of the concrete. And you have a 1-inch depression in your gutter from the lip of the gutter to the flow line, but you also have the drop, that same 1-inch drop, that slope drops the same. So you would maintain that 6-inch thickness all the way across that concrete. That doesn't mean that the back of curb is 12 inches. That might mean that the back of curb is 13 inches. So I don't know where you're getting that it was 12 inches. And maybe I've always interpreted it wrong, but I've always interpreted that detail to mean that concrete stayed 6 inches thick. And whether you measured at the lip or whether you measured at the flow line, it was a 6-inch thick concrete. That meant the bottom matched the slope of the gutter flow line, which drops that 1 inch over the 17 inches.
Okay, I totally see your point, Ryan. I appreciate you bringing it up. Let's look at type E real quick. So type E is calling out a 12-inch back of curb with a 6-inch. Now, granted, I have not, only thing that's changed on this detail is what's in red.
Yeah.
So there again, you have a 6-inch face, you have a 12-inch back, you have a 5-inch, and then you have, okay, so you have a 5-inch face. I'm talking through this. I'm not,
Sure.
this isn't a gotcha. I'm talking through it.
Yeah, absolutely.
So you have a 5-inch there. I would assume then, the remainder is going to be, you're going to have a balance of 1 inch, right?
Your 6 inches is measured from the top of the curb to the flow line.
Right.
Right.
It is. No, you're correct. You are correct. And then you have 6-inch. Yeah, I see your point. No, they're.
I think we.
Well, I guess
So Gene,
the vertical curb and gutter being the most frequent and common type of curb and gutter. And I guess the one I'm most familiar with, I've always interpreted that to mean that it was a 6-inch constant thickness. And if we're going to change that, or if we're going to all agree that it's never intended to be that way, then I understand what you're proposing here, and that doesn't change anything. But I guess I would ask that question: do we want it to be 6 inches, or does it matter? Is 5 inches okay at the thinnest section? I think that's a worthy question for all of us to make sure we understand what we're interpreting it as, or showing it as, at least.
And maybe talking through it, maybe another option to do is make the 6-inch minimum right below the flow line.
Yeah.
Right below the 3/4 radius, make sure that's 6-inch minimum, and then.
Yeah, and I think that matches with some of the conversation we had last month, where it was, if we took away the optional thing, then everyone's saying their concrete production rates go up because they'd have to add more concrete, not their production rates, but their
Yield.
expenditures or whatever you want to call it goes up because it takes more concrete if you don't build that. So they always build it. And again, that says to me that it's optional because it could be 6 inches min up to 7 inches thick at the lip, which is what I thought we were doing. Or if you don't want to do that, you're welcome to slope the subgrade and construct it so that it's still 6 inches thick concrete and it follows the slope of the gutter. And that's the way I thought we were doing it. But I would support it for sure being listed at the flow line and saying 6 inch min there.
Yeah, we could certainly look at going that direction, Ryan. I think that's a good point. Whenever years and years ago, whenever I did form inspection, you had a 12-inch form on the backside and you had a 6-inch form on the front side. But then to that point, you also had a sloped subgrade. You are potentially a sloped subgrade because they had cut grade.
I think real quick, Peter, I think Mike had his hand up.
Well, I was just gonna, as a reminder, because ADOT was mentioned, the detail that we were referring to and that were included wasn't to change any dimensions. It was just as an example of how we try to provide clarity when you have so many dimensions in a very tight window. So we have those two tables on the far right. Again, making sure that the gutter depression is clear as what we're intending, but also, just to primarily clarify some of these details where it's so busy. So that's all I wanted to say.
Yeah, thank you, Mike.
Peter, were you gonna?
I was just going to note that if you can leave the word optional in there, make sure you identify a pay line. So the contractor doesn't go ahead for that, assuming the pay line, because right now with the slope that's shown, that's the volume, or that's the cross section you're paying for. If you show it optional and drops it flat, now you're paying for that extra concrete. Now, maybe you want to, maybe that's the.
Yeah, and maybe the simple answer is just to go back to adding that 1-inch dimension and leaving everything else the same.
Just the clarity for the gutter pan.
Yeah, because that's where the questions, that's what really prompted this case for the committee members. What prompted the case was that dimension was missing in type A, where I have dimension equals 1 and I have it tied to that, the horizontal line there. That dimension was missing, but based on the last meeting and all the conversation that went back and forth, I looked at, all these other modifications. Maybe we just go right back to, brass tacks there and stick to the 1-inch dimension, add that and call it done.
Well, Gene, what about if you just put I think maybe Ryan mentioned, move that 6 inch minimum dimension over to the flow line and just say 6 inch minimum throughout, meaning that whole 2 foot horizontal 2 foot's got to be 6 inch minimum. Does that help? Does that help explain what we're trying to do here? Or?
Yeah, I think so.
I guess I'm lost in all the language. And what are we actually trying to do here?
Well, that's what I was trying to clear up is so these modifications that you see in red are what I gathered from the group at the last meeting. That's where we discussed this, it grew into something bigger than what it started off as, but really the intent was to capture the missing dimension of 1 inch between the lip of gutter and the flow line. That dimension was missing. And then we looked at changing the subgrade and eliminating, making that optional. I think we probably got lost in the weeds there. I'll clean it up.
If the contractor wants to save money on concrete, then he needs to put the slope into it and the subgrade. Otherwise
it's incidental.
It's incidental. And, I walk concrete and I see so much slobbers, it's like, they're obviously not caring about how they're forming it or when they finish it, and they're leaving all these slobbers all over the place. So I'm not too sure they may talk about trying to save concrete, but in practice, I don't think they're really doing it. So yeah. I don't have any sympathy for that part of it, their argument, I guess. So.
Yeah, I do
think. Hey, Gene, this is Warren. My only thought is you did mention Brian Gallimore. I can't remember what he brought up, but he did have some feedback on this. So maybe just run that by him one last time. Make sure you didn't see something else that beyond what we were talking about, how this could be clarified. But
Go ahead, Alec. Do they have existing forms or infrastructure that they use right now to do
Yeah,
these?
that was
things?
discussed as well.
Yes.
Yep. We didn't want to change any tooling for slip farm or anything like that. This case has been in front of Brian Gallimore. I've kept him up to date with the comments, but the original case that I had submitted, which I can reel it back to that, industry was totally on board with it. Hook, line, and sinker. They said that's fine.
I think just because of all the discussions we had here, I would probably suggest a couple of options, right? What would be the take if we move the 6-inch dimension right below the flow line, right? Because that's probably what the biggest comments we have on what's being presented right now. And if that throws a monkey wrench to everything, then maybe we can evaluate going back to, square one and just add the missing information. Because honestly, all the information you have here is good information to have, right? That the batter on the bottom is optional because it
The slope,
sometimes built
yeah.
and sometimes it is not. And that the critical dimension is the thickness.
No, and to your point, Mr. Chair, that optional, sometimes it is built, sometimes it is not. That is correct. And that's been verified through industry.
So I think it's valuable information what you have here. I think it's just mainly that minor tweak.
Yeah, we can move 6-inch minimum over to the flow line and then still keep that dimension as 1 inch for the slope.
I think you've got the key there. Your two items you care about are thickness and slope.
Yeah.
You want to make sure the water goes where it goes and you have minimum thickness. Beyond that, contractor build it how he likes. And you just have to then define paved lines.
Would it make sense just to put a slope on there instead of?
I think that
They're different lengths and, so that 1 inch on this one is gonna be different than a 1 inch on the type.
I think it's the rounding thing, right? What slope are we gonna put in there if it's just 1 inch?
For example, this one is 30 inches. This one's 24 inches.
No, but it's to the pan, it's just the pan dimension.
But if the slope is the same, they can't have the same dimension.
No, your rise over run's not going to change because from the lip of gutter to the flow line is still the same distance. 12-inch with a shiner. So the 1 inch would remain the same. Your rise over run's not going to change. Your slope's not going to change. Between type A and type F, and correct me if I'm wrong, but that's the way I see it. You have 12-inch broom finish plus your shiner.
So it's still it's a 17-inch dimension for pan on the type path, and is still a 17-inch dimension of the pan on the type A.
That's the way I'm reading it.
Yep. So
So
a
you're
1 inch drop on both is gonna give you the same slope.
the same slope. Your rise over run's not changing. So yeah, I could certainly we can move that over 6-inch minimum. Mr. Chair, if you want to open it back up for any additional comments, since we had a lot of dialogue on it just now.
Anybody else have any comments? If not, maybe we can get a cleaned up version.
Yep,
Let's go.
absolutely.
I'll have it one last chew before it goes to vote. Moving along. Let's go to item number 9, case 26 -04, revisions to section 602. Arvid? I was gonna say that long name of that pipe, but I'll let you.
Don't even bother. All we're gonna do is bring this up in the working group this coming month and talk about it in detail, just to make sure the working group is on board. And then we'll bring it back to the committee next month at this point in time.
Just remind me, the pipe material's already been approved, right? You
Yeah,
just
last
added-
year we added in 2 additional casing products as alternative casing options to allow for technology growth. And now we're just going in because I failed to properly change it when we updated the
Mostly a
materials.
cleanup case.
I did not go through and do all this. It just blew I skipped over it inadvertently. So I'm trying to get it fixed properly now. Yep. So we'll talk about it in the working group and then bring it back to you all cleaned up.
Thanks. We look forward for that case next month. Moving along to item number 10, it's a new case, 2605, revisions to stormwater details, 520 and 521. Jim, you want to introduce the case?
Yeah, thanks, Mr. Chairman. So, as you recall, last year we had a new case and spec to, or not, I mean, a new case just to require forming, actual form work be done on the sanitary sewer manhole base. So all this is simply going to do is just, carry it over to the storm drain base as well. So we're consistent, and that's really about it. So it's pretty simple, straightforward. So.
Oh, thanks for bringing that in.
Yeah, I think you're the one that brought it up, to address it. So we're doing that. So, I mean, it's really easy, but just to be consistent, it makes sense. So
that was mainly the point, right? So we standardize manhole base construction, and we don't have that discrepancy between sewer and storm drain. That way the contractors have the same expectation every time. So.
Yeah, and it came up again in Avondale. Another we got a problem. We got huge tons of concrete next to that's never got formed up, and it's causing a problem with another utility. And it's like, what the hell were they doing here? And it's just like, it just makes sense to do this. It's just wasted concrete and lack of control. And this really needs to be done. But
that's been my experience. And when you have really large pieces of pipes at weird angles, you have a behemoth concrete manhole base. So
yeah.
I know it's a new case. Does anybody have an initial comment?
I do. A question for you, Jim.
Okay.
On the 51-inch and larger manhole, and this might be just a lack of my knowledge on how this works, but my understanding is you have the 51-inch pipe that is turned on side and is flush with the flow line. There is no base, is there? And then it's encased in concrete. So your note 6 there, cast in place manhole base. Does that apply on this 51-inch or larger style manhole? And where is the base? Help me understand that part.
That's a good comment. We might need to change that to say, base and or encasement. We've done some where they're custom made, but again, then when they were outside of MAG at that point, but it probably should reference the encasement as well then.
So note 6 on this particular detail might refer to the encasement needs to be formed.
Correct.
Okay, that would make more sense to me than base, because I guess I'm not really understanding where base comes into play with this, because it's the pipe structure itself and then just encased. That would make more sense. Thank you.
It's funny that you bring it up, Brian, because the name of the detail is actually manhole base too.
Yeah.
I'm gonna change that.
I think it's used as a generic, base, meaning just
Not the shaft, right? It's
yeah,
the bottom part of the manhole.
Yeah, but we can clean that up in the note 6 just to clarify it. We'll leave the name as is for now. So
manhole haunch.
we could call it a manhole base unit.
Put the word haunch.
Yeah. Good comment, Ryan. Anybody else has any other comment? No. All right. Thanks again, Jim, for that case. Let's go into the outside of right-of-way cases. Item number 11, outside of right-of-way case 26A, new riprap spillway details, Peter.
Thank you, Mr. Chairman. So this is the extension from last year where we had the concrete spillways. Now several details have been added for combined either riprap alone or combined riprap or grouted riprap. There are several options. So we've proposed let's see, 3, 4, 5, 6, and 7 details to go with the 1 and 2 we had from last year. And one of the aspects that we looked at was, one of the questions we had given to us was, well, when would it be a maintenance issue or a problem for an agency to have riprap or grouted riprap? When do you see that transition from a maintenance perspective? And so what we did was some research on that and found that, yes, there is some logic to when you would either have ungrouted riprap, grouted riprap, or you couldn't use either because it would be so flat or so steep that you'd have a maintenance issue involved. The flat would be if you had riprap on the base itself that basically retained the silt, and you had riprap down there, either grouted or placed riprap, and the silt would not wash out. And so now you had a maintenance hassle. You'd either have to hose those out, you'd have growth, weeds growing inside that. So we did some research, and that actually has been looked at before. And it was primarily through the Army Corps of Engineers. They had some research on what are the minimum slopes, so there's self-washing going on. So what these details did was start incorporating some of those slopes involved with that. The other aspect was when you get so steep with riprap, ungrouted riprap, what is the point where you're going to start losing riprap down into the down the slope? So again, the idea was try to define those ranges of riprap. I think it was Pinal County had some details on that. So we combined a bunch of information into these details to put the dimensions of all of this and what slopes would be primarily minimum or maximum slopes for each condition. So if we go look at one of the detail. Oh yeah, and I know what I did was I ran around and I took some pictures and then I used Google Earth to find a bunch of other ones where some of these problems could be seen. Here's one of the options. You have a concrete base and grouted riprap sides. That's one of the options we put in there. That one doesn't seem to have any specific issue. You can do that. That's actually one of the most common ones you'll see around the valley.
Doesn't have any fall protection either.
It doesn't have any fall protection, true.
Not Mac, that's Google Street View.
I won't say what agency that's in. The one that does have fall protection, you'll see that one is kind of a different one, but that's ungrouted. That's grouted riprap that's flat, and that's less than a year, and it's already starting to gather sedimentation in there. I remember when that one went in, and how fast it started getting sediments in there. So those are kind of comparisons. Next photo would be that's a really good one of ungrouted riprap. You can't even see the riprap any longer. It's already filled up with sediment. It's a maintenance hassle. The other one below that, though, had a slope to it. And you can see there is some sediment, but is some ability for washing, and it had the curbsides on there. So the steeper it was, the more the material washed out. And so, like I said, took some pictures just to kind of get a feel for this. So what we have, the first detail is the spillway with just the ungrouted riprap. And Jose's already gotten me some comments. Before I even submitted it, I had some of them already cleaned up in there. I saw some of those. So some of those are captured. I'll take your comments and continue revising those to incorporate that. But this one is the ungrouted riprap portion. This was primarily taken from Pima County Flood Control District standards and how they were doing it. It's got a geotextile fabric below the base. There can be two placement methods. You can do a dumped placement or a tamped placement. I think we put in provisions for both of those in these ones. So let's go to the next one. Short on time, I don't want to spend too much. Okay, that's the next one. This is the grouted riprap option, where you've got it on the base and the bottom. Again, some different slopes are noted in the notes now that weren't there before. We took out that note that had slopes on the sides because that was not what was meant. So we've got the flow line slope down identified, which I think is what we were trying to get to before. The next detail would be with a concrete base and grouted riprap sides. Again, this is probably the most common. This took directly from the concrete spillway detail that we already had and adapted it with the grouted riprap sides. Typically, grouted riprap in this condition usually has a little 4-inch, or I think that's what's referenced on there, it extends beyond the riprap. And you can see it in most of those pictures. Sometimes that's even formed separately. I've noted on there. I've seen on the photos. And the last one, or last two, I guess we've got. Here's, do we have that one? Yeah, grouted riprap.
I think these are just the difference between.
The curb cut and the scupper.
Oh, yeah, that's right. We had two different versions. We had the scupper version and then we had the curb cut version. With curb cuts, it's probably more common. This is the scupper option that we were looking at before, and then 6 or 7 would be the other scupper version. Again, trying to capture the two sets of entrances and then the different options that are available. Like I said, I've already got Jose's comments. I'll be incorporating them to the next revision. Proposed that we look at those and get some comments and review these and see if there's other options I'm missing that we need to incorporate in there.
You still have one of our team members on your team?
Okay, that's where we got the
From
major
Glendale?
comment, yes, and we got the major comment on maintainability. And that's where we.
Yeah, I find it interesting. It's just like conveying wastewater, right? You
Mhm.
try to get that slope right, or it's self-scouring and self-cleaning.
What?
And you can do that with the riprap as well, but then there's a balance of not undermining the riprap
Mhm.
and washing it down into the basin.
Yeah, so went around and tried to look, I mean, there's certain steepnesses you wouldn't take a slope beyond anyway, so.
Yeah.
I think that was one limitation of it. You simply shouldn't, the slope shouldn't be any steeper than we normally would see, because of the basin shouldn't be any steeper. than
Right.
that.
You know, I would say that as prevalent as these are, I can't believe we never had a detail on it.
They're everywhere. They're everywhere. And it was great because you could go around and see good practices and lesser quality practices. It was easy to get the pictures that way. You could run around and start finding them like, well, yeah, we don't want to do it this way. I was at my son's apartment complex. I saw a really good one with ungrouted riprap and just noticed, oh yeah, there's no vegetation growing in it. There's grass on the sides that never grew up inside of it. They just spray it and it's self-cleaned.
That's good. Open it up. Does anybody have any comments? If not, this is a new case, so if you can take some time to review and share. Definitely the outside work right away working group would be happy for any comments on how to improve this detail. Anything else that you want to add, Peter?
That's all I've got for this one. Thank you.
All right. We'll go ahead into the working group reports. Jim, can we start with you with the water and sewer working group?
Sure. Thanks, Mr. Chairman. So we met on, the water and sewer working group met on February 17th, online through Teams. So we basically just, I think we had a little bit of feedback on Gene's case of the scupper. And then when Warren had an update on the tracer wire. So we had some little bit of discussion on that. You know, my thoughts. We've been using. I like to know who's actually been using this. We've tried to implement some of this stuff, and we've gotten a lot of pushback from contractors. It's pretty expensive, I guess. So I just again kind of reach out and I'm curious to see who's using this yet, and what kind of feedback they're having. And then our public works people are looking at it as well, just to see, okay, how, you know, what's the maintenance on this stuff, and you know, we put in these test boxes and stuff for terminations for all this stuff, and then you've got, you know, the builders, you know, they build the homes, you know, what's going to happen with that part of it, and so we're trying to implement it, and we're running into a little bit of static on it. So I'm just curious to see, because this is the time, you know, to get, you know, make any changes, you know, to get some feedback from it. So that's kind of what some of the discussion was about at our meeting. I don't know, Warren, you got any other thing you want to add to that?
Yeah, Jim, we're getting some pushback too. Obviously, the few developer projects we're getting just more or less clarity. And I think with this revision, we're gonna look at adding some options potentially to scale back as an option to the agencies some of the tracer wire requirements. I mean, it'll still be traceable, but for example, maybe not not having a grounding rod at every end, or there's some other options. So that'll be some things we can talk about in the working group. And then also, like you brought up, we kind of touched on this last year. You don't have to have an access box at every sewer service. You can still run the tracer wire out and terminate it and not have an above ground box and then have one at the next location down or so. So there's some ways to, to make it doable. But anyway, those are some of the thoughts. But yeah, I think there'll definitely be some revisions that we'll have to put together this year.
Okay, yeah, because I think when you look at it from a perspective as when you got so many services in a subdivision, it kind of amplifies everything, and so we need to look and see is how much is necessary. And you're right, I think we need more direction because I get tons of questions on it. So we're just trying to take a look at it, and so now's our chance to kind of clean it up. So I just want to kind of get that out there for the group and say, hey, are you guys enforcing this, or what are they doing with it? So thanks, Warren. We had a little discussion. We're trying to come up with a spec on standardizing mandrels and video. So I've got Rob on our team working on that. What else? Maybe, I don't know, we're still looking at maybe cleaning up some of the spec on the PVC pipe references to C900 just to be consistent with some of the other references materials. We just want to be consistent from the construction spec to the detail. Then the other thing, we had another item, a detail on the manhole adjustment rings. I know we wanted to, Gene brought that up. There's again some dimensions I think that it doesn't make sense. That just kind of always been in place, and so I don't think industry's following that anymore. So we're going to make some modifications on the adjustment rings. And we talked briefly about my case on the forms, and then just other possible cases that you might see is updating the mortar coating requirement. And it's not really the mortar coating. It's another. There's a process that apparently the industry doesn't use anymore for ductile iron pipe. So the industry people reached out to us, and so we just kind of need to refocus on that. And then the FRP folks, want to look at maybe expanding the use of their pipe for pressure pipe uses. The other thing that I brought up maybe is, is there any interest in doing HDPE for alternate water service? Kind of like what we did with the PEX A Municipex. So then again, we're looking to see if there's an opportunity to work with ADQ and maybe revise the extra protection specs. Arvid's aware of that, so we're going to try to work on that. I guess the county's looking at some modifications there, so I'm not up to speed on that, but there's some talk about the county working with them on it. So again, those old specs, if you recall, are from 2000 or 1970, so they're pretty ancient. So it needs to be updated. Because I know some of the cities are working, we're kind of working on a case-by-case basis with the county health department when it comes to some unique extra protection designs. So again, we want to use new technologies and maybe convince them to update the spec, which would mean probably, legislation to revise the Arizona Administrative Code, because it's all tied together that way. So other than that, we're going to meet our next month meeting. This month will be the fourth Tuesday, because we got 5 Tuesdays in the month. So we're going to meet on the March 24th. So that's really about it, Mr. Chairman. So
thank you, Jim. Outside of our working group, Peter?
Thank you, Mr. Chairman. We met on virtually on February 19th. Encourage people to attend. We had a little bit, I think there are probably some conflicts going on, but please please get to that. We're in the middle of trying to get several of these details out. We've already talked about the riprap spillway details. Those are presented. And so I'm not going to go into any more detail on those. The other major effort we have right now is on detention tanks. And we're, of course, Mr. Chairman, you know the effort going on that. We're trying to do the multiple tank options now for the CMP tanks, which was I think it's going to be a fairly short haul, try to get that one in. I think we've already got the basic stuff done. Now it's just a matter of showing what is necessary in the detail for multiple tanks. So that's moving forward. I would expect we'll bring that one forward. If not next meeting, the meeting after, but the next couple months, we're going to have that one coming forward to the committee. Now also the intent is to expand to other types of materials, both precast and cast in place. We have draft details moving forward with committee members on both of those right now. And we've got the markup. So right now, the working group members have been asked to review those, get comments back so we can get those ones also moving forward and try to round out the detention tank details suite that goes in the outside right of way. Other work that's going on, Wayne Colbank has volunteered to review the Section 220 riprap to update that to more current standards. That goes hand in hand with the details we're doing right now. It's really nice to get those both. So Wayne, we're hoping by the next meeting we'll have something marked up to move forward on those. We're looking, when we looked at the safety rail detail that City of Phoenix had, one thing we're looking at is there some sort of way to specify what goes on behind the sidewalk relative to slopes and drop-offs. City of Phoenix has a detail on that, so I volunteered to start marking up something there to where we can start looking at proposing some kind of appearance. What would be a point where you'd have to start putting in safety rail on the backside of the sidewalk, depending on the condition that sits back there, either slope and or drop-off. So we're going to move forward with that one. We thought that's going to become more important. Actually, again, driving around, I saw some circumstances where there's some existing retention basins very close to the back of sidewalk that, in my perspective, would be a hazard, even just for a kid on a bicycle. Your tire goes off the edge of the sidewalk and now you're down in the basin because it's such a close proximity that either probably we wouldn't want people to necessarily be putting safety rail up all over the place, but make sure there's sufficient room to where we prevent any kind of hazard, especially as we get into tighter and tighter spaces and look in low impact development. I'll start drafting that language next time. We also been encouraged, and Richmond has provided us the Texas A&M Green Infrastructure Toolkit. It's posted, I think, on our notes or through the committee, the working group, I'm sorry. So start taking a look at that and see if there's some other alternatives. We can be looking at other stuff behind the sidewalk we should be doing. Again, I think part of it, we did have a discussion on detention tanks and the maintenance perspective, looking at the other materials. I think I talked about that, and installation protocols and procedures. Our next meeting is scheduled on Thursday, March 19th at 10:30. It'll be a virtual meeting again and open to any questions.
All right.
Thank you.
Thank you, Peter. Materials Working Group, Alex, can you give us an update?
Yeah, appreciate it. Thank you, Mr. Chairman. Our last meeting, our chief focus was really trying to work through all the comments in 329, or excuse me, 326 and 719. I think, as of today, we've successfully done that. So I appreciate the help of the group. That's really a signature win for us. And I think moving forward, we want to continue that effort as agencies use that as a good opportunity as agencies are updating their addendum to bring other good ideas to MAG and trying to incorporate those. However, I think that'll provide us some great wins. Outside of that, there was some conversation about working, and this is going to go through the Paving and Technical Committee and Concrete Technical Committee at ARPA, looking at how we might be able to approach e-ticketing and if that's something we want to address within the MAG standard that was brought up. And then, of course, as always, as we're doing this consolidation of specification, if there's some way to look at an approved products list. So we're continuing that conversation. It's a slow mover. I understand that, but really, I think that provides huge value
to everybody who's using these standards.
All right.
Appreciate it. Thank you,
Thank-
Mr. Chair.
Thanks for the update, Alex. And I guess last, Warren, ADA working group.
Thank you, Mr. Chair. Yeah, we met last Thursday, February 26th, and kind of the similar topics that we've had in previous working groups. We went through the current cases that are in consideration, went through the current update on ProAg, nothing new there. Touched on Gene's case, which we already talked about, that came out of some comments from the group. Looked at the curb and gutter a little bit, nothing real fruitful there beyond we already talked about. But then we moved into some of the potential cases that kind of wrapped into Trevor Root provided the group in a draft of some isometric views for all the curb ramps that led to a lot of discussion. He provided a few different flavors and perspectives and detail on that we could all look at and decide kind of which one we'd want to use. Obviously, one of the big topics came in particular on a directional ramp, trying to incorporate some of the aspects on those directional ramps, showing the grade breaks, showing the bottom area and the turning space and those kind of things. So definitely going to be a little bit of work to get through the perspective of the isometric and then also where to put it. As we've talked about before, our curb ramp details are pretty busy, and that led to talking about some of the other agency details out there. We looked at Colorado DOT and some of the other DOTs that even ADOT, you have a little more real estate to work with at 11 by 17 than our 8.5 by 11 mag details to lay out types and information. So we have to come up with a series and figure out how to incorporate that. Also with that thought in mind that Brian brought up last month is making sure we don't get too far into the design aspect of it. So it's all kind of pure, consistent with the current mag construction detail aspect of it all. So definitely a challenge to kind of come up with something to provide more information with those kind of things. But so we're still working through that. At some point, we might have some isometrics that we bring back to everyone just to get everyone's perspective on if there's any preference from the larger group to let Jose maybe throw some thoughts into that too. I think we were going to do some type of vote either at the working group and maybe share it up. Jose, did you have any further thoughts on that idea?
No, that's just to pick a direction on how to update the details, right?
Yep.
There's a lot of options right now. That way we can focus on one and then keep the case moving forward.
Exactly. Okay. And then we had some of those other items like the crosswalk info also might fall into a series of information that we add supplemental information about what's required or its own details. So we talked a little more about the on-street parking, got some perspectives from some other agencies like Scottsdale, where sometimes the current draft I had showed the gutter in the street, but sometimes the agencies have the flow line at the back of the curb. So there's some different thoughts there. So again, if we're gonna move forward on that detail, trying to get that into more of a construction perspective that can be used. So that's going to take a little effort, but try to make some more work on that. Nothing new on the bike ramps. We talked a little bit about Marty's detail, which is similar to what Gene's working on, so nothing new on that one. The detectable warning, there's Jason with kind of related to Techway has offered to do a presentation on the detectable warning, tactical warning surface indicators. And it's not just what we envisioned for the curb ramp. There's other types that are being used too. So it sounds like it would be more beneficial to be an in-person meeting, and we could either do that through the working group, or if we thought the larger group would benefit from a presentation, we could maybe offer that up at an upcoming committee meeting. Jose, did you have any thoughts on that?
I think it, in my mind, Warren, it would benefit if we start at the working group and we schedule it with there, but we open it to any member of the main committee, see if they want to attend, especially if
That
it's
sounds okay.
In person.
That sounds good. Let's do that. Okay, then the speed cushion details, we had a little discussion on that. Thought was there's various ones in agencies that are somewhat unique. Kind of suggested Corey from Tempe might look at those other agency details and see if there's any thought to maybe moving forward with coming up with the MAG detail with, for example, like we do traditionally MAG type A, type B, type, come up with something if there's enough commonality between the other agency details. So that might move forward, but that's where that's at. And then our next meeting is March 19th. Jose, did I miss anything else?
No, I think you got it all. Warren, thank you.
You're welcome. Thank you.
All right, we'll move along towards the end of the meeting. Does anybody have any potential case for 2026 that hasn't been discussed with our working group? If not, we'll move into staff report. Gordon?
I have nothing to report this month.
All right, thank you, Gordon. Next item, general discussion. I do wanted to bring up, I don't recall the exact topic, maybe Alex or Gordon, you recall, is there like an invitation from ARPA? I believe Gene shared an email. I just don't recall, and he already left. You remember? I don't know what the topic was. I thought there was a training or a meeting coming up long.
The Educational Coalition has been hosting several different opportunities. There's been plant tours. I believe coming up, there will be a ADOT sponsored training on the change from Arizona to AstroTurf methods. And that will be coming up soon. I can make sure that the group has info on that.
Yes, thank you. That's the one I was talking about.
Perfect.
So, yeah, just for anybody that's interested, that definitely, I think we already had a case on this last year, so hopefully this covers a little bit more of the in actual implementation. So
this is kind of the nuts and bolts, that some of the chief changes between the methods and how that's going to be implemented.
Right.
Yes.
Thanks, Alex.
Absolutely.
Anybody else has anything to add on general discussion? Nope. All right. Request for future agenda items. Anything else that we haven't covered so far? I do want to share that next month's meeting, we're planning on another presentation from Hassan on providing a summary of a recent discussion that related to implementation or unification of specifications across the region. So definitely look forward to that conversation. Anybody else has a request for future agenda items? All right. Last item, comments from the committee. Anybody else wants to bring something, current event, other useful information to share with the committee? I have nothing. So with that, meeting adjourned. Thanks, everyone.
Thank you, everyone.